store values, okay? Now, Java expressions compute values, okay? So we call this sort of little formula we have here, this sort of thing here is called an expression, okay? This is called an expression. Another expression would be just, 3. That's an expression as well. It happens to be nothing to do for it. But these are expressions. They're expressions because they compute a value. As we say, they evaluate to a value, okay? It's like a formula to compute a value. And you've been writing expressions outside of AnyLogic for years, I can guarantee you. So when you were doing algebra and you wrote a plus b or a divided by b, that formula is an expression, okay? You've used them in Excel. You say a1 plus a2 in Excel equals a1 plus a2. That's an expression. So Excel's macro language is built up out of expressions. Expressions that operate on the contents of cells and use various built-in formulae, etc., as well as formulae you can find in VB. So these are examples of expressions. Some of these expressions return things of different types. 2 times 5 will return an integer of 10. 1.0 divided by 3 will return a floating point value, approximately a third. A plus b times c, well, this a plus b quantity times c, what that returns depends on what a and b and c are. If they're floating point, it'll be floating point, etc. A greater than b will return what sort of, when evaluated, this would return what sort of type. It would be a Boolean, yeah. This get connected agent name, that's an expression. It computes a value. So we take this reference to myself and I say, get my connected agent number I. Maybe I is 3. So it gets me the agent that's connected, the third agent, fourth agent that's connected to me. And then what's its name? It gives me back a reference to some string. And that's the value returned by that expression when it's evaluated, okay? In the process of computing this, of evaluating an expression, in some cases there would be changes to so-called program state. And so in other words, it may update something. So sometimes in computing an expression, there's something that changes. So for example, this expression might have I++ on it, in which case it's going to give me a value back, but it also changes the value associated with the variable I. We're going to get to that later. It's kind of an advanced issue from the point of view of this presentation. Okay, so here are some common Java expressions. There's a set of Java expressions that are literals. They're already the values directly. And then there's expressions that are comparison expressions, like those. You'll notice that this A equals B. This is one of the bigger trip-ups for beginners in Java and C-like languages. Languages like C, C++, Java. This Objective-C, A equals B is a test. Are A and B equal or not? It returns either true or false, just as that A greater than B returns true or false. We distinguish that from A equals B, which means give A the value that's in B. The value A should become the value that B had or has. And then there's some mathematical operators that can be used for expressions. So A plus B, A minus B, A divided by B, A times B. And sometimes, confusingly, Java overrides these things. So plus can be a mathematical operator, or it can mean put two strings together. Put them, append them, okay? Now, another one is dereferencing. So when you see something like A dot B, what that's saying is, okay, take the reference A, and then get the field or method, no, there's a property or method, called B, okay? For example, we saw that, we see that right down here. at this dot get main. So whatever A is, whatever this refers to, we want to call get main on that. Okay. Here's a ternary operator. We saw this before. So we have some predicate, question mark A, colon B. What this is saying is if the predicate is true, we use A, otherwise we use B. That's an expression. It evaluates to a value, and it's either the value A or the value B. Which of those it is depends on whether this predicate is true or false. So, you know, the predicate may test, for example, what's the sex of the person. If they're male, it will return one thing, female will return another thing, like that. And then there's some of these expressions that cause changes. So A equals B is an expression that computes a value, whatever is in B, but it also changes A in the process. A++ changes A, but returns the value before it changed it, before it incremented. And then a method call, like this dot get main, might change something depending what's in this method, but it returns a value. In this case, it returns the main, reference the main associated with this. Okay, okay, so here's some additional operators you'll see. A, and B. So this is a logical and. So this should be a Boolean, and that should be evaluate to a Boolean. Those should evaluate to Boolean. And it returns true if and only if A and B are both true. Evaluate to true. A or B is a logical or. So A, and then two vertical bars B. And so it's actually testing, okay, is A, is either A true or B true? And exclamation point A is a logical not. It means, is it not true? Okay. Then there's an operator, it's an indexing operator, A of, in brackets, 20. So this is the 21st element of A. In other words, it's, if this were 0, it would be the first element of A, 1 would be the second element of A, etc. And this is the get connections number element of A. And A here has to be an array. It has to be a collection of values. We'll be talking about arrays in a bit.
Is that a universal feature of arrays when they start at 0?
Yes, in Java. In Java. And it causes no shortage of frustration because different languages learn with different things. And generally speaking, for a lot of engineering-oriented languages like MATLAB, they'll start with 0. Does Mathematica start with 1? Sorry. Does it start with 1? Okay. So I get confused between MATLAB, Mathematica, and Maple. I use all three. I forget which one starts with 1, which is 0. I thought MATLAB starts with 0 and Mathematica starts with 1, but in any case, whatever. You're basically check before you write code for it, which it starts with. This is a method call operator. If you have f being the name of some method and you call it with 2 and 3 as arguments, those pass 2 values with 2 and then 3 as parameters, so to speak. And then if you have strings, maybe you do a plus, we do a concatenate them. So if A is foo and B is stir B is bar, this will create foo bar. So it'll put it all together in one string. So one's a prefix and one's a suffix of the subsequent string. Okay, so when you're reading expressions, a tremendous amount of what you'll see in Java code is just expressions, okay? And what I'm hoping that you come out of from today's lecture is some understanding of how to recognize the expressions and how to understand what they do. We're going to further talk about, and maybe today, maybe Friday, statements. And statements are, a lot of what's in a statement is built up out of expressions. Not all, but a lot. So expressions are key to understanding the meaning of programs, and the key is to remember they compute values, okay? They may do other things in the way, like changing things, but they compute value. So if you see an expression like this, I've tried to color code it about the order in which it's executed. So you have to start looking left to right. Okay, so I have this reference A, and then I ask of A, I call its getConnectedAgent method with this argument I. So I'm asking for its I minus 1, excuse me, plus 1, agent to which it's connected. So if I were 0, it would be its first connection, conceptually speaking. And if I were 2, it would be, or 1, it would be its second connection. So I'm going to consider I have this reference A, I get its connection. That gives me back a reference to some person out there. I call this to get that person's name, and then I ask for its length, the length of that name, and that gives me back a value, right? It does many steps on the way, but each of these steps is just computing a value, and then it uses that value, like this value here, call getConnectAgent, gets back a value, it's a reference to some other person, calls that to get the name, and then that's about a reference to a string, and it gets its length, okay? As a property that's strung. So expressions like this are routinely strung together in this way, and you have to learn to get comfortable with kind of reading them from left to right, kind of innermost to outermost. And this is where a lot of, you have to think through in sort of a mechanistic way, okay, what's getting computed each step to understand what's computed by the whole thing. You have to kind of ask yourself, okay, what's getting computed as you're going along here, so that when I get this value back at the end, what does it relate to? This value at the end, length, it's not getting anything with the length of A directly. Instead, it's getting the length of the name of the I plus 1 connected agent of A. Mm-hmm. And to reason that through, you have to go step by step. Okay, so that's about expressions and values. Expressions compute values. And when we look at code, we're going to try to understand what those expressions do. So if we go and we look at the code that we created today, and we look at that, for example, those statistics, these are expressions. They are computing a value. The value they are computing is a Boolean. And we are asking again, I argued before that we're considering a given person in the population. We know the statistic is being chunking through and being applied to each person in turn. This is the current person. We're asking for their state chart. And of that state chart, we're asking, okay, what is this current state person not recovered active right now? So that's an example of an expression there. This item.age, the average of item.age, this is an expression, okay, it's the person's age. So the value of this is their age, okay?
So,
Yes?
so can you think of it as going from like big to small? So we'll start you're getting more and more specific with the information you're trying to calculate. So I start with, so with the example you just gave, so
Yeah.
it seems like you're getting more and more specific to point to exactly what it is you're trying to do. Does it kind of work like that?
Well, okay, so I think you could, so it's true that you want to, I'm going to need to distinguish two types of sort of the orders in which you want to think about it. So it's true that to understand what you're trying to do, it's important to think from, okay, big picture, what do I need here, right? So if I wanted to go compose these statements, if I wanted to put this together, if I had a general need to compute the length of the ith connected person's name, I would start with an understanding of that need. And then I'd say, okay, how am I going to go about this? How am I going to get there? And to go about it, I'd have to be thinking mechanistically in a process, okay, what do I have now, and how am I going to get to where I need to go, to get that information? So what I've got now is A, and suppose I know I want to get the length of that person's, of the name of that person's I plus 1 connection. Okay, if I've got A, first I have to get a reference to that person to whom they're connected, and then I have to ask for their name, and then I have to ask for the length of that. That's right. And so I may have a high-level understanding of what I want to accomplish, but generally speaking, in thinking about how I get there, I have to do it in a sort of step-by-step way of building up, as it were, the different pieces to it. Does that make sense? Now, it's true that sometimes I go in a stepwise way the other way. Like I'll say, okay, so I know how to get the length of a name. How am I just going to get this name whose length I need? And then I say, well, okay, I know how to get the name if I have a person's reference to a person. So how am I going to get that person's, the reference to the person? And then I could think of it sort of going back, chaining back that way. That's a legitimate way to do it. It's just in terms of how it's executed, how it actually performs this, it's in this kind of way, left to right, sort of building up. Does that make sense? And so here, like, yes, I want a thing that will count me the number of susceptible. How am I going to do it? Well, it may be useful to think of it, okay, I need a true or false thing. How am I going to get it to compute whether it's true or false? Well, I'm going to be asking, is the state active? And what am I going to ask if the state active? Well, I have to ask a state chart. And whose state chart? Well, it has to be the item that's given to me. So, yeah, of the person involved. Yeah, exactly.
So it's like you're saying the person.
Yeah.
I care about the person.
Yeah.
Now I'm doing the state chart. Now I'm going to get some specific information.
Yeah. So I guess I want to distinguish between what order it's sort of executed as it's occurring. Like, what is this going to give me? Like, okay, so I could look at this and I could say, what is this going to give me? I'm looking at your code and I'm saying, what is he trying to do there, right? To do that, I need to read sort of left to right in this mechanistic way, right? And to be confident that what I put down is correct, I need to think in this mechanistic way. But to figure out what goes here, you're absolutely correct that often I'll say, okay, what do I need and how am I going to get there? Okay, first let me figure out, so the analogy that was given in one 1980s book on programming was, assume for a moment that you have a big brother or big sister who can solve some problem for you. Think in a stepwise way, okay, what do you know how to do now? And just imagine they'll take care of the rest. So focus on that thing you know how to do. What is it you know how to do? And maybe what you know how to do is to ask if a certain state is active. And put aside for the moment how you're going to get the state chart associated with it. Okay, now that we figure out how we're going to ask if a certain state in a state chart is active, how am I going to get the state chart I need, right? So you break it down in a successive way into smaller and smaller pieces, in short. And that is often this backwards process, because you know where I'm going to go, and then I kind of figure, okay, well, I know I've got to get there, so kind of what's the next step back from that? What's the next step back? If only I knew how to do that, how am I going to do that? Okay, and you sort of wind your way back. And sometimes you find yourself going back many levels, and sometimes you find yourself only going back a few levels. And then it all kind of makes sense. Oh, okay. And often what you're thinking at each stage is, okay, what information do I have, and how can I use that to get this thing, right? And so you're kind of working your way back. So in short, to reason through what it's doing, you need to think mechanistically. To get that expression, often you do think back like that. So great question. Fantastic question. Any other question on that? Okay. Incidentally, I would argue that the thought processes that you go through there are not terribly different from some of those. Like if I asked you, okay, sit down and create a system dynamics model that shows X, Y, or Z, you're going to need to be thinking about, okay, where do I need to go? I've got these pieces. What do I have to do? Okay, I kind of know how to do this part. Let me do that. And then, okay, there's got to be some way to So in a way, that whole design, this is an issue of the design process writ large, rather than just Java code in any way. Okay, so any other questions about Java expressions before I go on to variables? Because there's a very close relationship here. And I think it's really important to ground you with variables. Okay, so variables are names.